Hello everyone, my name is Jude, and this is EdgeTrackr, my submission for the 5G Edge Computing Challenge with AWS. I'm sure we've all used delivery or taxi apps on our phones, and the first thing you notice in all of them is the giant map right in the center. How many times have you stared at the location indicator, hoping that it gets closer as the seconds go by? You hope for it to move, but nothing really happens. And then all of a sudden it jumps around, and the next second it ends up right at your doorstep. Well, whether it's hyperlocal delivery services, tracking packages, or watching the cab arrive in the middle of the night to your pickup location, location trackers have always seemed to be a little bit janky. It's understandable. Companies probably don't need to track every single step of your pizza delivery guy. But maybe a more accurate last mile tracking mechanism would definitely help me avoid running around my apartment following the scent of my large pepperoni. Well, here's my solution. I present EdgeTrackr, a simple two-tiered architecture for location tracking that utilizes edge computing and 5G to make for a much better user experience and possibly a more cost-efficient backend. I achieved this by utilizing two layers of location tracking. All drivers connect their devices to the servers on the wavelength zone layer and update their locations at a pretty frequent pace, probably many times a second, through a WebSocket. We then have a batching mechanism that batches and sends these locations at a more relaxed pace to the server in the second layer, the general availability zone. This is where the heavy lifting is done, such as price prediction, driver allocation, payment, customer support, etc. But that doesn't need sub-second level data. This way, the backend server can focus on heavy requests, and the edge servers can serve a responsive stream of locations to the customers. So if you're expecting your driver to be around the corner of your block, you'll be impressed at how easily you can find them. This is not just plain talk. Here's a demo. We connected two devices to the edge server over a cellular connection, one for simulating traffic load for 500 drivers, each updating their location at 60 times per second. That is 30,000 events per second. And the other one that shows the locations updating in real time for an end user. I resorted to using 4G LTE for the experiments since I did not have a 5G enabled connection, but 5G is just going to make this experience even better. This doesn't just have to be for delivery. What about smart traffic signal management? Cars can update their locations at a frequent pace. This can be used for accident detection on the edge server and smart traffic signal management on the backend servers. The same can be extended to games, allowing for multiple players on a map to engage in real-time events such as time-sensitive puzzles, while the backend servers can handle trade, battles, and messaging. Edge computing changes the way we model data processing systems altogether. It enables close-to-user compute and cost advantages if utilized well. 5G, on the other hand, enables a responsive, latency-free user experience. When used for the purpose of location tracking, 5G makes edge computing seem seamless, and the framework that we have just built here allows for extensive use cases. Thank you.